prove square root of 2 is irrational. Irrational means it's not a fraction. And the rational means it's a fraction. So when we say rational number, that is the same as saying it's a fraction. Okay, we know that not all the numbers are fractions. So in this video, we're going to prove that square root of 2 cannot be written as a fraction. So the proof we're going to use here is called by the way of a contradiction. And if you have learned discrete mathematics, you may have learned how to prove this, or number theory class. If you have not taken these two classes, I'm going to explain how to do that in this video. So we do it by way of contradiction, which means we assume the opposite. We want to prove square root of 2 is not a fraction, but we're going to assume it is a fraction and see what kind of contradiction we can get. Is a fraction. And so in the end, we will get some kind of contradiction. And whenever you get a contradiction, and you can say how we got this contradiction, because we had a false assumption. And if the assumption is false, which means the opposite is going to be true, and that tells us square root of 2 is not a fraction. So the important thing here is we want to get a contradiction after we assume square root of 2 is a fraction. Okay, so this is how you're going to prove the homework. Square root of 3 is irrational, and you can follow the proof here. Okay, so since we assume it is a fraction, we may be able to write it as in the fractional form. But we don't know what fraction it is. Actually, it's not going to be a fraction, so this is just a false assumption we're doing here. But we can use how to write fractions. We use a and b, and we also assume here a and b are relatively prime. When we say relatively prime, which means a and b, they don't have any common factors. You should have learned common factor, greatest common factor in algebra class. Here we just talk about a factor. They don't have any factor in common. For example, if you have 4 over 6 and they both have a common factor 2, and we can reduce it to 2 over 3. So we always assume that this fraction is going to be in this format, simplified format. It's not going to have, the top and bottom would not have anything common. And the contradiction we're trying to get is going to be like that. We're going to assume, since we know that a and b, when we pick the fraction, we make sure a and b don't have any common factors. But after we do some algebraic work, and we're going to find that actually we found out they have some common factors. That's the contradiction we get. Okay, so let's square both sides. Now the left side, from algebra class, we know square root of 2 squared is 2. And the right side, when we square the fraction, you square the top and square the bottom. Okay, now we multiply. We want to get rid of fractions, so we multiply both sides by b squared. We multiply the right side by b squared over 1, the left side by b squared, which is the same as b squared over 1. And we can cancel b squared and b squared on the right side. So the right side becomes a squared over 1, which is just a squared. And the left side, we get 2b squared. By looking at this we started with square root of 2 equals a over b, assumed that this is a fraction. And we use algebra, we got this new equation, 2b squared equals a squared. And from the observation, or actually this is something we can also prove, but we're going to skip the proof here. If a number multiplied by 2 that's definitely going to be what we call even number. For example, 0, 2, 4, 6, and so on. So we don't know what b is, but it doesn't matter what b is. When you multiply b squared by 2, when you multiply any number by 2, any whole number by 2, and you're going to get an even number. So 2b squared is even. Just observation. By the way, I also need to mention a and b here, they're both integers. Well, integers a and b. So a and b cannot be decimals. Okay, and since a squared is equal to 2b squared, that tells us, because we're going to switch the left side and right side, if 2b squared is even, then a squared is even. So then a squared is even because they are equal. If a squared is even, then we know a has to be even. I mean, this is something we can prove, but we will skip that. So a is even. Okay, and if a is even, we can write a, assume a equals 2 times an integer. So how do we describe an even number? Using algebraic expression. Because any even number is always a multiple of 2, so that's why we can assume a as 2k. So of course k here is also an integer. K is an integer. Okay, now we're going to next plug this expression a equals 2k into our equation again. So a right here, I'm going to replace it with 2k, and the right side we copy it, 2b squared. Now use algebra again. 2k squared equals 4k squared. Square 2 square k equals 2b squared. And we divide both sides by 2. So the left side, 2 cancels 4. We end up with 2k squared on the left. And 2 cancels 2. We get these 2 cancel out. So we just get a b squared on the right side. The left side show this, so it's reduced to 2. And by looking at this new expression, 2k squared on the left equals b squared on the right, and we can get a similar assumption, because if 2k squared is even, that means b squared is even, and then b is even. So we get similar results, conclusions. Then b squared is even, and so b is even. Okay, so now what we're going to look at is these two conclusions we get. A is even, which means it's multiple of 2. B is even, that's also multiple of 2. And here's the contradiction. What is the contradiction? When we pick the fraction for square root of 2, we assume that a and b don't have any common factors. But now we got a contradiction. A and b are both even numbers. They should. So a and b, at least they should have 2 in common, have a common factor 2, which is the contradiction. That's a contradiction right here. A contradiction. Because that's contrary to our assumption a and b don't have any common factors. And how did we get this contradiction? Because we had assumed square root 2 is a fraction. Now we got a contradiction, which tells us our assumption is false. If our assumption is false, the opposite will be true, which tells us, so I can say, therefore, square root 2 should not be a fraction. Simply put, is irrational. Just going to put it, is irrational. Okay, so this is the idea of the proof by contradiction. We assume a false assumption, and then we get a contradiction. This contradiction tells us our assumption is false, and therefore the opposite of our assumption should be true. So for example, square root 2 is a fraction, the opposite would be not a fraction, which means irrational. Well, in the homework, and we you want to prove square root 3 is irrational, so you can follow this and prove it.